Hi, I am Dipokanti Kumar, and today I am going to discuss on the work efficient realistic data generation framework for semi-structured tabular inference. So first of all, what is tabular inference? Tabular inference or tabular NLI is similar to general NLI. Only difference is that in tabular NLI the premises are table. For example, you can see the table on the right side, and we can see the hypothesis from H1 to H3. Now our task is to decide whether a hypothesis is entail, neutral or contradictory with respect to the premise. So in this case, Janet Leigh died in the fall of 2004 is entail. Janet Leigh was an only child is neutral because it cannot be inferred from this table, and Janet Leigh was born on the east coast of the USA is contradictory. Now what are our contributions? First of all, we proposed a semi-automatic framework for data generation from entity-based tabular data. Secondly, we extend InfoTab's dataset and create a large-scale human-like synthetic data using the semi-automatic framework, and we named it AutoTNLI. Thirdly, we demonstrate the AutoTNLI is quite complex, and we show the benefits of using it as an augmentation data for InfoTabs. Now, why semi-automatic data? So manually created data is extremely expensive, and humans may leave artificial patterns such as they might stick to some keys more than the others. On the other side of the spectrum, we have the automatic data, which is computationally efficient, but it cannot generate linguistically difficult sentences, and also it is difficult to incorporate reasons into automatically generated data. What about semi-automatic data generation? It can produce large-scale dataset at reasonable cost while retaining data quality. That is, we can incorporate reasons into it because we have human in the loop here. Now, what is our framework? So we have a table. A table consists of key value pairs. For example, here key 1 has value 1, value 2, key 2 has value 1 to value 3, and so on. And then we made a set of all values that contains for each key the possible values that could be there. Using the table and the set of values, we generate a counterfactual table. So for creating counterfactual, we use three operations: add, substitute or delete. Here you can see for key 1 we added a value 3 prime. For key 2 I substituted a value 2 prime, and for key 3 we again substituted a value here. Now we give these two tables, the original key value pair that we had and the counterfactual table that we have, to the sentence generator, which then generates two sentences for us. One is entail, another is contradictory. So for creating the contradictory, we also have to give it the set of all values. Now to the sentence generation part. So for each category, we wrote key based rules with 4 types of reasoning: temporal, numerical, spatial and knowledge and common sense. For example, here we have Janet Leigh was born before 1940, that is temporal. The age of Janet Leigh is more than 70, which is again derived from born and died years, that is temporal. The Janet Leigh has one child, all children. It is a contradictory statement here, and it's numerical since we can see here she has 2 children. And Janet Leigh graduated from University of the Pacific. It is a common sense. Now, as I already mentioned, while creating counterfactuals, we had used one of these 3 operations: add, substitute or delete. So here as an example, this is the original and this is the counterfactual. First of all, we substitute the died date here. Secondly, we removed the one of the names from the children category, from the children key here. Then we substituted again the alma mater here from University of the Pacific to University of California, and then the key occupation was absent for Janet Leigh. We add here a value to that key which is scientist. So now similarly from this counterfactual table we can generate sentences with using the same key based rules that we had before. So here we generate the age of Janet Leigh is more than 70. Janet Leigh has 2 children, which is now contradictory. Janet Leigh graduated from the University of the Pacific, which is previously was an entail, but now it's contradictory because we have substituted the value here. And Janet Leigh is a scientist, that is an entail because we added the value scientist to the occupation key. Next we had to generate premises so that a model cannot directly take table as an input, so we have to give it some premise on the basis of which it's gonna infer. So for each key here, for example for the born key, we generate 3 paraphrased sentences. For example here this state is placed here, here and here in these 3 sentences, P1, P2 and P3. So at the end of the whole framework, what we get is from the original table we get the counterfactual table from the counterfactual table generator, and that goes into the sentence generator, which gives us the entail and contradictory sentences. Now using this framework we obtained around 164 sentences per table, and overall it came to around 1.4 million premise hypothesis pairs. Now these are the questions that we asked after getting the data. So let's see each of the questions one by one now. The first question is, how challenging is AutoTune for the task of tabular NLI? So what we're trying to see here is, can AutoTune be used as an evaluation set? So here while using AutoTune for evaluation and standalone dataset, we use 3 types of split. First is category, second is key or entity, and third is paraphrasing. An entity consists of a few keys. So for the category split we kept 5 categories in train, 3 in dev and 3 in test. For key or entity split we kept 5 entities in train, 3 in dev and 3 in test. And for paraphrasing we only chose 1 paraphrase for each key, and that's it for the train, dev and test split. Now to the results. For checking how good it is for evaluation, we checked for 4 settings. First is without fine-tuning, second is fine-tuned on info tabs, third is fine-tuned with MNLI, and fourth is fine-tuned over both MNLI and info tabs. Now without fine-tuning gives an accuracy of 50% for each split, which is expected. Now comparing MNLI and info tabs fine-tuning, MNLI gives better results than info tabs in the category split, and info tabs give better result than MNLI in entity split. There is not much of an effect in the paraphrasing split. Now when we use MNLI plus info tabs for fine-tuning, we see that it is the best result that is obtained among all 3 settings. Now the second question is that, is fine-tuning with training set beneficial for the tabular NLI task? So even for this we check in 4 settings. First is hypothesis only, second is fine-tune on AutoTune, third fine-tune on MNLI and AutoTune, fourth is fine-tune on MNLI followed by info tabs and then AutoTune. So for the hypothesis only we get an accuracy in the range from 53 to 66%. Now MNLI plus AutoTune gives a better result than only AutoTune, and MNLI plus info tabs gives better result than auto TNLI, but MNLI followed by only auto TNLI is slightly better than MNLI and info tabs plus auto TNLI in the entity split and the paraphrasing split. Our third question is, can auto TNLI be effectively used for data augmentation, that is implicit knowledge addition, to enhance performance over info tabs test sets? So for this we had 3 test sets available to us from the info tabs dataset: alpha 1, alpha 2 and alpha 3. Alpha 1 is similar to train set in terms of domain and lexical structure. Alpha 2 constrain instances that are similar lexically to alpha 1, except that the intel and contradict labels are manually flipped by minimal perturbations in the hypothesis sentences. And alpha 3 contains categories that are not present in the train set. Now even for this we had 4 settings. First is only original tables, second is original plus counterfactual, third is MNLI plus original, fourth is MNLI plus original plus counterfactual. So comparing the original and original plus counterfactual, we see original plus counterfactual shows improvement in alpha 1 and alpha 3. MNLI plus original gives better than no augmentation in all cases, and MNLI plus original plus counterfactual is better than MNLI plus original in alpha 1 and alpha 2. Interestingly, in alpha 2, MNLI plus original plus counterfactual is better than all other settings by at least 1.39%. Now, how useful is auto TNLI in scenarios of limited supervision? So what we want to ask is, can we use auto TNLI with limited supervision? For this we use 5%, 10%, 15, 20 and 25% of info tabs data for training under supervision. Now in the first case, for the test alpha 1, we see that MNLI plus original plus counterfactual is clearly the best in all cases of alpha 1. In alpha 2 we see that MNLI plus original plus counterfactual and MNLI plus original are quite close and always give the highest accuracy. In alpha 3, MNLI plus original is at par or better when 10% or less than 10% data is used, and MNLI plus original plus counterfactual gives the highest accuracy when greater than or equal to 15% data is used. One thing to note is that the auto TNLI data, that is original and original plus counterfactual, even they help the model give a better accuracy than no augmentation in all alpha 1, alpha 2 and alpha 3. So at the end, what we get from this our work here is that first is we get a semi-automatic framework for generating data from tabular data. We show that can this data be used as an evaluation dataset, how good it is as a standalone dataset, and can it be used as an augmentation dataset with limited and full supervision. And at the end we also showed that this dataset can be beneficial in adversarial circumstances. Thank you.